Hello friends, this video on DNF clock elements part 9 is brought to you by examfear.com. No more fear from exam. Start with the electronic configurations of these metals. But now since we are deeping into the electron level, atom level, let's do a recap on some of the basics of the atoms, electronic configuration. See, the atom is the basic unit of the matter. It is a very dense central nucleus surrounded by a cloud of negatively charged electrons. This is something we have seen. This is how atom looks. It is a basic unit of matter and it has a very dense central nucleus, very dense if you see, very small. And this whole thing is a cloud of electrons, negatively charged electrons. And they keep moving here and there with a very high speed. And that's all we have atom, right? This is very dense. And if you see, this is very dense and you have a very big space, and in this space the electron keeps revolving. Okay, so if you see cricket ball, if the cricket ball represents the nucleus, then the radius will be about 5 kilometers. So if you take a cricket ball as the nucleus, a small cricket ball as the nucleus, the radius of the atom will be 5 kilometers. Such a big distance it has. If you see the quantum model, this is how the atom looks. These are my the inner one is my nucleus, very small dot I can make. This is my nucleus, and then we have the black dot which I just treated the nucleus, and then we have these electrons, different colors electrons, and they just keep jumping here and there, and these form the clouds. They jump at a higher speed. Just to show you, I have shown a very slow speed, but actually they move around with a very high speed, and they move around in some orbitals, some path, right? Or some there's a probability that probability zone, you can say, and that is what we call orbital. That is quantum model. If you want to learn more about this, you can watch my videos on the quantum model where we explain this properly. In fact, the equations of the quantum model also were discussed. Okay, and if you talk about the orbitals now, so we have s orbitals, we have p orbitals, right? So s orbital only one type because it's spherical. P orbital we have three types. So we'll see that this is s only one type. P orbitals actually we have px, py, pz, right? Three types. This is nothing but the combined of all three. This is how it looks, p orbitals. And then we have d orbitals. D orbitals 1, 2, 3, 4, 5 types. Please note this is not a type. This is just a combined of all. Actually, there are 5 types of d orbitals. The electrons moves here and there, here and there. So each orbital will have 2 electrons. Correct. And then we have f orbital shape. So there are 7 f orbitals, different types. Okay. So if we talk about the F-Boy principle, the principle that is used to write the electronic configuration, it states that in the ground state of the atom, the orbitals are filled in the order of their increasing energies. We have seen that, and this is the order of the increasing energy: 1s, then we have 2s, then we have 2p, 3s, then we have 3p, 4s, then we have 3d, 4p. So it is not, if you see, it is not following any what do you call 1s, 2s, 2p, 3s. It has some order, and we have studied this in the above principle. Again, if you want to understand more about this, you can watch the previous videos where we explain this above principle of filling of electrons. Okay, and if you see, we have a term called penultimate and anti-penultimate shell and orbitals. We'll use this term, so I'm just explaining it to you now. Penultimate is the shell before my final shell. So if this is my final shell or valence shell, right? Valence shell. A shell before that is my penultimate shell. Okay. Please know I'm talking about the shell now. Same thing. Anti-penultimate shell is a shell before penultimate shell. So if my final shell is 4, okay, or let's see this figure actually. This is the order we have: 1s, 2s, 2p, 3s. So we have 1s, 2s, 2p, 3s. So if this is my final shell, last shell, this is my penultimate shell, this is my anti-penultimate shell. Okay. So now let's talk about the electronic configuration of D block elements. So let's talk about the electronic configuration of the D block elements. The first D block element is this one, scandium Sc. So what is the atomic number? 21. 21 will write the electronic configuration 1s2, 2s2, 2p6, 3s2, then 3p6, p has 6 element, then 4s2, and then 3d some elements. Okay, 3d with some number of electrons we don't know. Let's count now. So 21, 2, 4 plus 6, 10, 12, 18, then 20, and then 1 is required, so it is 21. So this is the electronic configuration. So if you note 4 plus 6, 10, 12, 18, 20, 21. So if you note, the nearest noble gas is argon. So this whole thing is actually the electronic configuration of argon. So I can also write this as argon 4s2 3d1. This is what I can write. And actually you will see that I'll show you the electronic configuration of this. In fact, let me write the electronic configuration of few more, then I can write the general statement on the electronic configuration of D block elements. Let's take the another element, next element, titanium, Ti22. Okay. So now if you see titanium, the atomic number is 22, only one more than this. So it will be all same, only this D1 will become D2. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, it will be 3d2. Same thing I can write, this whole thing I can write as argon. This becomes argon 4s2, 3d2. Right? So if you see, this is the electronic configuration. Let's take the third one. V is vanadium. So V is vanadium 23. So it will be same as argon. Argon is 18. I can write shortcut 18. And then I have 18. And then I have 5 more. 4s2, 20, 3 more. It will become 3d3. Correct? Chromium is 24. So argon I'll write. Argon will take care of 18. This is 18 actually. And then 4s2 will take care of 20. 18 plus 2, 20. And my atomic number for chromium is 24. So it will be 3d4. But if you see, there is a catch here in chromium. The catch here is, see, 4s and 3d orbital, the energy difference is not that much. So if one electron jump from 4s to 3d, then the electronic configuration you get for chromium is 4s1, 3d5. So in this case, if you see, 4s is also stable because it is half filled, and 3d is also stable because it is half filled. The maximum number of electrons in 3d orbital is 10. Thus, because of this, the chromium will have this configuration. Okay. In fact, there is a very, very small difference between 4s and 3d orbital. So, and you will see a lot of more exceptions here. And there are different school of thoughts for this. Actually, some people say that this 4s orbital, when you talk about the energy of the orbital above principle, that holds true for smaller number of atoms, smaller number of electrons, or smaller number of atomic number molecules or atoms. But see, actually the energy of orbital depends on a lot of factors. If you go for the higher elements like this one, atomic number 24, 42, these kind of elements, right? So here the energy of this D and S orbital depends on a lot of factors. Sometimes the d orbitals has lesser energy than s orbital, and thus it gets filled early. I'll not confuse you more with this. First understand this concept and then we'll try to understand the exceptions, why we have more exceptions. The next is Mn, manganese. Atomic number is 25. Argon takes care of 18 electrons. 4s2 takes care of 2 electron. 18 plus 2, 20. And then you have 3d5. 20 plus 5, 25. So that is my manganese. Iron is 26. Again, argon takes care of 18 electron. 20 electron plus 6, 26 electron. No confusion. Then we have cobalt, that is 27. Again here, argon takes care of 18, 20 plus 7, 27 electron. Then we have nickel. Nickel is what? 28. So here also argon takes care of 18 electron, and then you have 4s2 that takes care of 2 electron, 20, and then 8, right? 3d8. Then we have copper. Copper is 29. Here also argon takes care of 18 electron, then 2, 20, and then 9, 29. But here also if you see, if one electron jumps from S to 9, and since the energy level between 4s and 3d is not that much, you get more stable configuration. You see, both are half filled. Sorry, this is half filled, this is full filled, right? So here this is also not full filled or half filled, this is just half filled. But this is half filled and this is, sorry, this is full filled. This is half filled, this is full filled. So this is you get for copper. And then you have zinc. Zinc is 30. So the electronic configuration, argon is 18. Then you have 4s2, 20, and then 3d10, 30. Total is 30. This is the electronic configuration of zinc. So if you see the electronic configuration, the pattern, you will see that the pattern of the if you can generalize electronic configuration is n minus 1d 1 to 10 and ns 1 to 2. You see here the d orbital has 1 to 10 electrons, correct, and s orbital has 2 or 1 electron, right? So s has 1 to 2 and d has 1 to 2, 10 electron, correct. This is my inner d orbital and this is a outermost s orbital. And please note, there is a very small energy difference between n minus d and ns orbital. We'll see that. Okay. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.